All right, here we go. Question number 4 from our 1316 homework number 2 in MyLab Math. They want us to graph the following function, show at least 2 cycles. Use the graph to determine the domain and range of the function. And so the first thing I'm going to do to get started, I'm going to recopy that function over here. We're dealing with a cosine function this time. And in order to get the graph, I'm going to illustrate my 6-step method for graphing sinusoidal functions. Again, I did this in problem number 3, and I'm going to illustrate this again in this problem. Number 4, first step, we need the starting point. And the starting point is determined by the trig function. So if we have a sine function, we would start at the origin on the y-axis at 0. If you have a cosine function, you're going to start at the value of a on the y-axis. And remember that a is the coefficient of the trig function. So for our problem, we're going to start on the y-axis at 1. In this case, a is 1. Okay? Step number 2. If you have a phase shift, you have to deal with it now. Phase shift has to be done at step 2. But since our value of C is 0, and I can already tell some people thinking, what you mean C? Okay, so let me see real quick if I can demonstrate that. Let's see, erase plus 0. Do you see that I don't have any constant added or subtracted to the angle? It's just 6x. It's not like 6x plus pi or 6x plus 2. There's no number there. That number, if it existed, would be the value of C. But for our problem, our value of C is 0 because there was no number there. And that means that we're going to have no phase shift. Okay, so if there's no C, there's no phase shift. And then we can move on to the third step, which is wavelength. Okay, for a sinusoidal function, for sine, cosine, secant, or cosecant, the wavelength, which is also the period, is 2 pi over b. And if we scroll up, the value of b is the coefficient of x. So our value of b is 6. And so our wavelength, our period, is going to be 2 pi over 6, which will reduce to pi over 3. So our wavelength, our period, is going to be pi over 3. That's going to be a fairly short wave. Next, step number 4, you're going to need 4 spaces. If you're doing this by hand, a hand-drawn graph, you're going to need 4 spaces at step number 4. And then you can lay out your points. And the last step is to connect the dots. Now, let's go through and demonstrate how all of these 6 steps come together to produce a graph for us, okay? So we've got step number 1, starting point. We said we have a cosine, so we're going to start at positive 1. So up here at 1 is where we're going to start. And then if we had a phase shift, we would then shift this point either left or right. But since we don't have a phase shift, this point is going to stay right where he's at 1. Step number 3, wavelength is pi over 3. Now, since I'm starting on the y-axis, what I'm going to do is I'm going to come over here and I'm going to say, that looks about like pi over 3, okay? And then from start to finish, that's going to be a wavelength of pi over 3, okay? I'm going to start on the y-axis. I'm going to finish at pi over 3. And you always finish where you start. So if I start up at 1, I'm going to finish up at 1. And then I need my 4 spaces, okay? So if you can see from start to finish here, I've just got one big space. So I need to cut that in half and then half the halves. And that gets me 1, 2, 3, 4 spaces. Now the reason I need 4 spaces is because the hash marks are where my points go. So now I'm going to lay out my points. I'm starting up in the air, so I'm going to come down to the x-axis, and then I'm going to bottom out at -1, and then I'm going to head back up to the x-axis, and then we'll finish up at 1. And then you can play connect the dots and make a wave. Well, as best as I can draw it. I'm sorry, I'm not much of an artist, but there's one complete wavelength having the amplitude of 1 and the wavelength of pi over 3. Now, if we wanted another cycle, if it says draw 2 periods, then I would simply go 1, 2, 3, 4, and I would continue the pattern, okay? Down, down, up, up. And you just play connect the dots again. Okay, now if you think about this, the first wavelength from here to here was pi over 3. So then the next wavelength, that would be another pi over 3, which means that this hash mark would be 2 pi over 3. So you can tell what to label that because the period counts by pi over 3. Okay, so now what we're going to do is see if we can turn our manual graph into an electronic graph. Let's do this electronically. We're going to click to enlarge the graph. You've got a sine tool and a cosine tool. We're going to use the cosine tool and click on the graph, and then we're going to change the settings to fit our function, okay? So our amplitude was 1, so we're going to leave the amplitude 1. Our period is not 2 pi, it is pi over 3, okay? Now, what I did to get the pi symbol is I typed the letters pi. In MyLab Math, if you need the pi symbol somewhere, you can type the letter pi, and it'll make the pi symbol. And then I'm going to hit the divided by on the keyboard, and it makes a fraction. So there's my period, pi over 3. Remember, we had no vertical shift and no phase shift. And since we're starting at +1 on the y-axis, we do not need to reflect about the x-axis. If this graph had started at -1, then we would need to choose the reflection about the x-axis. We don't need that this time. And then we're going to hit enter and close this. And hopefully you're going to see that this squiggly wave looks something like what I've drawn here. If I come over to my notes here and do one more wavelength, 1, 2, 3, 4. Now this is just for me, just for fun, okay? One more cycle would end where? What would that end point be? Well, remember we're counting by pi over 3, so that would be 1 pi over 3, 2 pi over 3, 3 pi over 3, which is pi. So we need to make 1, 2, 3 complete cycles in a distance of pi. And if you look real close over here, you're going to see that it makes 1, 2, 3 complete cycles by the time it gets to the pi symbol, okay? So I feel good about that. We're going to click save. And before I click check, I'm going to pull up Desmos, and we're going to look at Desmos and see how Desmos looks on this, okay? So pulling up my Desmos, sliding that over. We're going to type in the function y equals cos parentheses 6x and enter. And then let's drag and scroll. The Desmos is the coolest thing. You can zoom in by scrolling, and then we're going to check some points here, okay? So there's my first point. Notice from peak to peak, one complete cycle by pi over 3, 2 cycles, 2 pi over 3, 3 cycles at pi. So this Desmos is verifying what we did manually. Man, that makes me feel good. Let's check this answer. Hot dog. All right. Now we need the domain. And we know the domain of every sinusoidal function is all real numbers. And the way you do that in interval notation is it's negative infinity to infinity. Again, it's all real numbers because the domain are the values that x can be. And this wave is going to continue forever left and right. So it's going to go all the way back to minus infinity and then all the way forward to positive infinity. It's going to cover all of the x values. And the last thing they want is the range, and that the range of the values that y can be. And notice that the lowest that y can be is -1, and the highest that y can be is 1. The graph is going to be contained between -1 and 1. And do you know why I'm using brackets? It's because those points are included. You actually get to touch at 1 and -1, so we need the brackets because those are included. Yay. All right, so I hope that was helpful. If you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.